So hey guys, welcome back to my YouTube channel. So this is the second video in sliding window playlist. So today we are going to solve another problem, and that is the find the first negative integer in every window size of k. So this is the second problem in fixed size sliding window problems. So what we actually going to do is, before moving further, before solving this problem, I will explain everything that goes in this problem, every concept that goes in this problem. First of all, I want you to revise what exactly the sliding window concept is. So what we did in the last video. So in the last video we wrote a general format for sliding window. So we take two pointers I and j, and we run for j, and we do some computation, and we keep increasing our window size until the window size is less than k. And as soon as we hit the window size k, what we do, we store the answer here. So as we hit the window size, we store the answer, and after storing the answer, we maintain the window size. What we do in maintaining the window size, we increase the window size by right side and we decrease the window size by left side, right? So we did that in the fixed size sliding window, right? So we are increasing the, so here we are increasing the window size from the right side, and we are decreasing the window size by left side by removing the last I element from our computation, and we are increasing that. So I hope that this is the format of sliding window and this is clear for you. If not clear, we will also see that same thing in this problem. So okay, so let's try to decode the problem step by step, right? Okay, so there is a something which I want to tell you, like in coding, right, in coding, whenever you see like first negative number, like first negative or first positive, or just right, or let's say next positive, or next negative, or next greatest, or let's say next smallest, or something like that. So whenever we have to find the first negative, last negative, next negative, previous negative, so whenever we want to track some order, right, whenever we want to track some order in any kind of problem, whenever we track some order, we always should at least once think of the stack, even stack is made just to store the order of incoming or outgoing elements, you know that. So we first have to, like, we use the stack only to store the order of elements, and so that we can arrange them. So this is the use of stack. If you are not familiar with stack, I will also explain that. So and the second thing, whenever it says like every window size k, or every subarray of size k, so this problem could also be like this in every subarray of size k, it will be the same problem. So whenever the question talks about subarray, substring, you at least once think of like sliding window as well. So here we have two concepts, so we need to apply the stack concept as well as sliding window concept in this problem. Why stack problem? Because we already talked about that whenever we see these keywords, we at least once think of stack, right? So what exactly I'm going to do in this problem, let me erase these things, because you now are familiar with this thing. Okay, so now what exactly I'm going to do, let's say what I'm saying, let's say I is here, j is here, and I made a stack, right? Let's say this is a stack, and this is 0 index, this is 1 index, this is 2 index, this is 3 index, and whenever we say stack of -1, it returns me like the last one, right? Okay, fine, that's cool. So at this point I have j here and I have I here, so we will iterate. So initially I is equal to 0 and j is equal to 0. At now, for now, j is at 0. So we have to check if 2 is negative, only if array of j will be negative, I will be adding in the stack. So let's say 2 is not negative, 2 is not negative, I will move at this here, I will move this here, right? Is minus 1 is negative, is minus 1 is negative, I will include that, right? And now check the window size. Window size is 2, so now no need to store array, no need to store answer, because we have to find answer only when the subarray size becomes 3, right? When subarray size becomes 3. So for now don't do that anything. Now again increase the j, because we haven't found our subarray of size 3. Now as I increase the j, and now I increase the j, I will check, is that minus 7 negative? So yeah, that is negative. I will add that in our stack. And now we will check, I was 0, j is here 0 1 2. Now we need to see that did we hit the window size? Yes, we did hit window size. As soon as we hit the window size, we need to find the answer. So what will be the first negative? The first negative was here, right? And this value will be stack of minus 1, stack of 0, sorry, stack of 0. This will be stack of 0. So I will add in answer, I will add minus 1 into answer. So this is our first negative in this subarray of size 3. This is a subarray of size 3, so this is our first negative number, right? In this subarray our first negative number is still minus 1, right? But let's say I have got this subarray. What will be the first negative number? In this subarray I will have the minus 7 is the first negative number, right? Now after we talked about after hitting the window size, what we do, we stored the answer. Now we found the answer, and now what we do, we maintain the window size. Now we maintain the window size, right? Maintain the window size. I is here, j is here. What we do, we decrease the window size from left. So this is our left, so we decrease the window size, right? How could I decrease the window size? We will increment I by 1, and if I increment I by 1, our window size will be decreased, and it will now become from here. As we increase I will be here, and now the window size will become 2, right? Window size will become 2. And now as we decreased our window size, I decreased our window size from left side. I need to remove this element if it exists in our calculation. So for now our calculation is our stack. Does this 2 is in our stack? No, it does not in our stack. It is not in our stack. So if 2 is not in our stack, we don't do anything, we don't need to do anything. And now for now our window size is 2. We again increment j, so j will come here, and now we see that we again found a subarray of size 3. Now again I will check here, did we hit the window? Yes, we hit the window. And again we will append minus 1, because in this subarray minus 1 is still the first negative number, right? So now what we do, we again increment I from this side to this side. Currently I is here, so I is here, so I need to increase this I from here, and if this minus 1 is in our calculation, I need to remove that, right? So this minus 1 stack of 0 is still in our calculations. We will pop off, right? We will pop off, and I will be at this point, and j will be at this point. Now we see that our window size is 2, so again we increment j, and now our window size will be, after incrementing j, if this minus 16 is negative, I need to add that, so minus 16 will be there. And now after appending that, I need to check if we hit the window size. Yes, we hit the window size. So what will be our first negative number in our subarray? So in the stack of 0 we had popped it off, so stack of minus 1 will return minus 7, so minus 7 will be our answer. So hope that this is clear. Now let's try to code up, right? So how will we code up? We will make a stack here, stack equal to as an array, I equal to 0 and j equal to 0, while j is less than length of our array. Let's also take an answer array, right? Answer array. And what I will do, if array of j is negative of negative, we will append stack in the, we will increase, we will add in our stack, right? And the index will be -1 because we will add up at the end, right? So we will add up, right? By default this is -1, right? And now if we hit the window size, that is j minus I plus 1 ever becomes is less than equal to k. If this is less than equal to k, means we didn't hit the window size. We will keep increasing j size, right? And if else if we hit the window size, what we do, we store the answer. What we do, answer dot append and stack of 0. So this will be our answer. Now we need to maintain the window size, maintain window size. How would we maintain the window size? We trim from, like, we decrease length by left and increase by right. So how would we do that? What we do, so we will remove array of I if it's in our calculation. So if stack of 0 is equal to array of I, we will pop that stack dot pop 0, right? 0 index, because the recent number will be stack of 0. That could be the answer, so we will remove that. Else else what I will do, I will increase I plus equal to 1 and j plus equal to 1. So this is our whole code. I hope that you understood. So we will remove this value if it's in our stack of 0. If the value is in our stack of 0, we will remove that. If not, we will simply increase I plus 1 and j plus 1 in every condition. So I hope that this is clear to you, and if you have any doubt, please let me know in comment box. And thanks for watching this video. In the next video we will try solving occurrence of anagram and all these things, right? So thanks for watching this video. Have a nice day.